In this thesis, we provided two corrective measures. One of them was redirection that we demonstrated in the previous video, and the other one is adaptive and secure service composition engine that we are going to discuss and demonstrate in this video. The goal of the ASSC is to find the optimal service orchestration for the current SOA. What's the service orchestration? If we look at the current ticket reservation service, we see there are multiple categories of services, and we have selected one service from each category, and they are connected. For example, TR1 is connected to A1, DL1, and UN1 services, and each of these three services is connected to BN1. So this creates a service orchestration or the way a topology that is used for invoking other services in SOA. Now, the challenge here is that during the lifetime of the SOA application, all the services may change their behavior, their trust value may drop or may increase. Also, there may be other parameters, for example, the quality of service parameters that may change, or in general, we may have multiple context information that are important for the SOA to take into account. For example, in this demo, we considered two main constraints. One of them is the cost, and other is delay. Cost means we associated one cost or value that is associated with every service. And the second parameter is delay, or how much is the execution time, or delay of calling a single service. Here, for example, for each of these services, we assume the cost is 10, the default cost, and also for the delay, we have developed AOP aspect that collects inside the PME that collects all this execution time or delay from every service and report them back to the TM service. But since we want to see explicitly how these parameters affect the ASSC and how changing the cost or delay can change the outcome of the ASSC algorithm, we want to explicitly assign them here inside the GUI. Now let's start by an example here. We assume the default cost for each service is 10. For the total cost, since we need to select 5 services, we assume the total cost that should be the upper bound of the cost of the selected services is going to be 50, and the total delay is going to be 500 milliseconds for the total services. And then we can explicitly set other quality of service. These parameters for every service, the cost of every service or delay of the service. Each of them individually can be changed. That we will show how we can change them and see the effect that it has on the ASSC later. Now let's just run the basic algorithm here and see the outcome. We can change to see how ASSC changes the service. We can change the trust value of AA1 from 0.85 to 0.54. It means during the execution of the SOA application, the trust value of AA1 drops, and then we want to reconfigure the whole orchestration by ASSC. After calling the ASSC from which is a web service is available through REST APIs from TM service. After calling ASSC, it gives the information for the most trustworthy service composition, and after enforcing, we will see that this change happens by changing the TR1 to AA1 to TR1 to AA3. By dropping the trust value of AA1, the ASSC have been able to reconfigure the service to maintain the highest trust. and we see that the ASSC has improved the trust value from 0.74 to 0.77 by changing this reconfiguration. Another source of change beside trust is cost and delay. Now let's see that, for example, the value of UN1 may change. The total delay of UN1 may change, even though it has a higher trust value, but we can change the delay of UN1, for example, to 400 millisecond response time. Now, since the total delay of 5 services needs to be 500 at most, this is the upper bound, then I mean ASSC should exclude UN1 and select another replacement for UN1. After getting ASSC and enforcing ASSC, we see that this reconfiguration happens by changing the TR1 to UN3 and UN3 to BMO. Basically, this replaces the UN1, even though the trust value of the UN1 is higher and the total trust value has dropped. But we needed to replace this one to maintain these constraints that we have in this system. And we can also change the other parameters here. If we want to see, for example, BN1, replace the BN1, we can change the cost of BN1, for example, to $40 per month or whatever. And after changing, we can see how ASSC reacts to this change in the context of the service. We see that after this change, BN1 is excluded again, even though the trust value is higher, and we have selected BN2 since BN1 cannot meet the constraints in the system. So let's try the example. We can assume during the lifetime of the system, the trust value of DL2 increases to 0.65 and DL3 increases to 0.75, and then we will see again how it reacts. We call the ASSC, get the most suitable service orchestration from the trust manager, and this shows that now the change, the call from TR1 to DL1 is changed to TR1 to DL3, or we have replaced DL1 with DL3 here. Another features that can change, that we can see how it affects the ASSC is a DoS attack. We can easily select each of the services inside the SOA and apply the DoS attack. And the DoS attack basically slows down the service and makes it to respond much more slower than its actual response time. For example, let's see if we attack DL1, what happens by applying the DoS attack. If we enable it here and come back to ASSC, we try to invoke the ASSC again and enforce it into the current setting. We see that by attacking this DL3, we come back to the DL1. Even though the trust value of DL1 is lower, but we have replaced the DL3 by DL1 since DL3 is much slower here. And this shows that ASSC correctly can react to the context of the SOA application. And we can, see if we can assume that DL3 has been recovered from the DoS attack at some point. After we recover DL3, we try ASSC again to see if it can picks up DL3 again instead of DL1, since it has a higher trust value. And we see that yes, DL3 has been selected instead of DL1, since it's no longer under a DoS attack. So ASSC, as we can see, is able to easily detect all this contextual information and react based on the constraints that we have defined toward maximizing the trust value of the system. Try applying the ASSC algorithm on a generic service graph. I just created this new graph from 8 different services and 4 categories of services. As we can see, each category has 2 services, and we can run the service invocation, and we see that S1, S3, S5, and S7 are accessed. Then let's try the reaction of ASSC when we change the value, the trust value of S4 from 0.5 to 0.9, for example. After changing trust value S4, then it should be replace the S3. We can change the total cost to 40. As there are 4 categories of services, and we need to select 4 services, and the total delay to 400. There are again quality of service parameters for 8 services that we keep the initial values here. Then we call the ASSC and enforce the ASSC. We see that the reconfiguration happens, and instead of S3 we call S4 here. It shows also that the composite trust has improved from 0.63 to 0.67. Another interesting aspect of this UI is that we can stop the current provisioning. We can insert some new services. For example, I will insert 2 new services, one in category 2. Let's change the class of service to C2, and I will add another service in category 3, and we can improve. Let's remove this extra edge and change the trust value of S9 to 0.94, and change the trust value of S10 to value larger than 6.5, like 0.74, and we can provision the service again, and after that we can try the ASSC algorithm to see whether it can detect any more trustworthy service orchestration. Right, now we can see that the system has been reprovisioned again, and let's try by querying ASSC again and see how ASSC reacts to these changes and to the new request. We query it, and let's see how enforce reacts. As you can see, enforce can successfully select S9 and S10, since they have a higher trust value compared to the previous selected nodes, and system configuration changes. As we can see, the composite trust also has increased to 0.71.